Welcome again. Thanks for watching this video. Today we're going to go over amides. And so in preparation for our class, here is your video. So you'll see that amides they look like esters where they'll have, and I'll switch slides right now. We have a carbonyl group attached here, and instead of an oxygen, we have an amine or an amino-derived group, making this general form of an amide. Will look like this. Now, a secondary amide is a carbonyl attached again to nitrogen with an alkyl group on the right end here. So what we have then is carbonyl attached to an alkyl group as well as a nitrogen attached to another alkyl group, making it a secondary amide. You've seen these types of configurations and these types of designations before when we've done alcohols. So it shouldn't be too new. The tertiary type of amide is a carbonyl attached to nitrogen, and we have it on the right flank here by two alkyl groups, and your carbonyl a third alkyl group. So amides typically are looking for a carbonyl attached to a nitrogen. Now whether it's primary, secondary, or tertiary, that's what you're really looking for, carbonyl and a nitrogen. So like esters, we're going to look at how amides are formed first because it's going to help us figure out how to name it. So the formation of an amide, or the synthesis of an amide, begins with a carboxylic acid, right? And that's where we get that carbonyl group. And then we have an amine, or you could have ammonia if you can just have ammonia actually if you want to form a primary amide. We'll get to the different kinds of amides and how they're formed in just the next slide. But carboxylic acids and an amine or ammonia in the presence of a strong acid. Now here we see that hydrogen is rather water is, you have a minus sign here, so it's a condensation reaction like esterification was a couple of functional groups before, and you haven't seen this yet, but it's just another way to represent the loss of water. And what we'll get is your OH together with a hydrogen group will create your water, and that's how that water is formed. That's how that H2O byproduct is created to finally get your amide. Now, if we have an alkyl group attached, nitrogen, another alkyl group attached to that, of course, from the carboxylic acid, that would make this a secondary amide. So, looking at how it's synthesized, if we have a carboxylic acid and a primary amine, that would produce a secondary amide and as a byproduct, H2O. Continuing that, a carboxylic acid, if we have a secondary amine, that would produce a tertiary amide. Just there's a pattern there, right? And you don't have to memorize this part. This isn't something you have to memorize. As long as you're able to picture this, draw the general forms, you'll see that it will form this. A secondary amine will get not carbonyl, a secondary amine will get an extra alkyl group attached, which will make it a tertiary amide. Right, so hopefully that made sense. Here's an example. Here we have a carboxylic acid. We know it's a carboxylic acid because we have a carbonyl right here and a hydroxyl group attached to that carbon in the carbonyl. So 2 carbons long, that makes it ethanoic acid. Right here, then we have methylamine, right? So a primary amine in the presence of a strong acid, and you can just write H plus. We'll get a byproduct of water, right? This OH here, hydrogen here. Then we get a carbon nitrogen bond, pretty stable bond there, and we'll end up with your typical carbonyl nitrogen, which will tell you that this is an amide. And when we try to figure out what kind of amide it is, primary, secondary, or tertiary, we see that we have a carbonyl group attached to an alkyl group. We have a nitrogen attached to another alkyl group, which makes us a secondary amide, and byproduct is water. So again, going back to the top here, carboxylic acid, primary amine, creates a secondary amide, and we see that happening right here. Two alkyl groups, making it a secondary amide. Okay, so nomenclature. Again, don't usually read through these nomenclature pieces, as you've noticed, but just a few things to point out here. we are going to change the ending, so the suffix of the parent of the carboxylic acid. So similar in naming to esters, we take out the oic acid from the carboxylic acid, and that's why we looked at its synthesis before nomenclature in this case. So the oic acid is replaced by the new suffix amide. So going back here, we'll get to naming in more detail, but going back here, we see that ethanoic acid, you would take out the oic acid and you would add amide. So that would be that portion of the name. We haven't put it together yet, but that portion of the name would be ethanamide. Okay, so that's a suffix. The alkyl group not having the carbonyl group, so that's the amine. We're going to name that as well, but before we do, the amine, when it is the amide rather, when it's secondary or tertiary nature, we do have to make sure to list the nitrogens as if they're locants. We're going to call it the N designation, as we did with amines. We're going to continue using that N designation. So we have carboxylic acid, primary amine. We're missing here, don't have this written, so you might want to add that. A strong acid, you can just write a proton here, hydrogen H plus. And then this portion, formerly the carboxylic acid group, this is now your methyl substituent, right? This methyl is attached to the nitrogen from that primary amine, and we've identified that as a methyl substituent. So to name this, right, I know I kind of glossed over that second point over here, but we're going to get to an example right now. We take out from ethanoic acid, we take out oic acid and add amide. So that's this portion right here, ethanamide. Then adding your N designation, and we'll get to this last point here, but adding the N designation, we see that this alkyl methyl substituent is going to be is methyl, and the methyl is attached to nitrogen. So we say N for the locant or for the N designation, N methyl ethanamide. Now, this N prefix or the N designation, as we like to call it, it's not always written for secondary amides, but for consistency, we're going to write this designation. So just for this class, and it might be different next year, whenever you do this again, you won't have to do it, you may not have to do it, but for now, just to keep things consistent, we're going to write that N designation even for secondary amides. Okay, now the real stuff. Let's practice this. So we have first identify which portion of this molecule it came originally from an acid, from your carboxylic acid. And what you're doing is you're looking for a carbonyl group. So C double bond O off of a backbone of 1, 2, 3 carbons. So you have not methane, rather not methanoic acid, not ethanoic acid, but you get propanoic acid. Take out the oic acid part of it, and you're going to add the suffix that we need to add for amides. I'm going to go backwards here. We add amide, and the end is going to be propanamide. Now, as for the substituent here, we have 1, 2 carbons, which makes it ethyl. This ethyl is attached to a nitrogen. This is going to be your carbon 1, right? Carbon 1 is right there. Taking this out now, we get N as your designation or locant, N-ethyl propanamide. Okay, next example. Now, this, I think, with the pattern of naming that you've learned in this nomenclature and with your experience, you should be able to figure this out. So although I don't have a timer on this slide, now I think I'll put one in later, but I don't have a timer right now, as we don't really see in class. What you might want to do is pause. Pause the video, try naming this yourself, and I'll give you a second to do that. All right, so now let's go over what to do here. This is a stick diagram, different from the previous. 1, 2 carbons. Carbonyl group is here. We know that this left portion is your former carboxylic acid. 2 carbons would have made it ethanoic acid. Take out the oic acid and add amide. We'll work backwards like we usually do. And we get ethanamide. Now we have nitrogen, right? So this carbonyl nitrogen group here, we know that this is an amide. Of course, lessons on amide, so it's pretty easy that way. But I'm saying that for when you're writing a quiz, test, or exam, and you have all these functional groups mixed in, this is how again you would identify it. So this nitrogen isn't attached to 2 alkyl groups. So we see that this is a tertiary amide. So one alkyl group here is methyl, another one here is methyl, and we have 2 of them. Because we have 2 of the same, we're going to add a prefix, a certain prefix. when we've done this from the very beginning. The prefix is going to be di, methyl. Two methyls, we get dimethylethanamide. Now we use the N designation, the N locants as well, and you treat them as locants. So you're going to see this happening. NN. Just as if you would do if you were on a simple alkane and you had methyl groups everywhere or several methyl groups, we would state the locants in commas. You do the same thing for your nitrogen groups, so for your nitrogen here. So N dimethyl ethanamide is your full name. Next, 3 more examples. We'll start here. First, we'll do C. I'll go over it and then I'll give you a second so you can pause the video and try to name this yourself. So identify that this portion is your former carboxylic acid, 2 carbons long. It would be ethanoic acid. Take out the oic acid, add amide. We get ethanamide. Now, nitrogen attached to 2 alkyl groups. This will make this a tertiary amide. So you know you're going to write your designations, your N designations, your N locants. You're going to have an N locant here, N locant there, you N something, N something. Let's first figure out the alkyl group. So here's your methyl, 1 carbon. Here is another alkyl group, 2 carbons. So we get ethyl. Now placing them as you would normally, alphabetically, even if it were on an alkane, we get E before M. Pulling this back here, we get N ethyl. Treat your nitrogen as if it were a numbered locant. So usually the rule was letters and numbers are separated by hyphens. Treat your nitrogen as if it were a number separated by hyphens. So N-ethyl, that's why I call it a locant. So N-ethyl hyphen N hyphen next alkyl group methyl, listing it alphabetically, putting it all together off of the parent. Well, first methyl, off the parent ethanamide. So N-ethyl, N-methyl ethanamide. Okay, now I don't think I gave you a pause there, but I'll try to remember this time. This is now, again, your carboxylic acid portion, looking for that carbonyl. 1, 2, 3, 4 carbons long is parent chain, 4 carbons long. Would have been butanoic acid, except 1, 2 off the second carbon, we have an alkyl substituent. Okay, so we got to deal with that. So first, think of it as if, name it as if it were just a carboxylic acid. So you can ignore this group over here to the right, pretend it's a carboxylic acid, and it would have been 1, 2, 3, 4, and that's where I'll say pause, try naming it yourself. Okay, so if you did pause, we can continue now. So 1, 2, 3, 4 butanoic acid, but off the second carbon we have a methyl group, so name it exactly as that. 2-methyl butanoic acid. Don't change that, don't change the root name, just change the ending. Take out the oic acid just as the pattern goes. You're going to add amide. You see that we have 2-methyl butanamide. This is a secondary amide. 1 alkyl group here, another alkyl group attached to the carbonyl, and we get 2 carbons, which makes it ethyl. Write your N designation, put it all together. N-ethyl, 2-methyl butanamide. Okay, slightly more challenging this next example. Just move this aside over here. Right, now we have 1, 2, 3, 4. 4 carbon backbone, what used to be a carboxylic acid with this carbonyl, and you have to think, do we start with this? This is always carbon 1 where the carbonyl is, so carbon 1, 2, 3, 4, or we could have gone down and numbered the other way, 1, 2, 3, 4. Turns out both the same, it's going to give us the same nomenclature, so if it were just a carboxylic acid, we would have 1, 2, 3, 4, where on the second carbon we have a 1, 2 ethyl group attached. That's enough for hints. Pause, try naming it yourself. Okay, so let's continue. Again, as before, it's 4 carbons long. On the second carbon, we have an ethyl. So we're going to have 2-ethyl butanamide, similar but a little bit more involved in the previous example. So 2-ethyl butanamide. Going to move this back. Let you see that again. 2-ethylbutanamide. Moving it back though, just so we can see the structure. Here we have a tertiary amide, nitrogen attached to a methyl group here, nitrogen attached to another methyl group here. So two of the same means are going to use a prefix. Because there are two of them, the prefix is going to be, go ahead, say it, di. Right. So N, right, designation, because it's the same, N, comma, N. Treat your N as a numbered locant hyphen, prefix di. What are the alkyl groups? Methyl. So NN dimethyl, 2-ethylbutanamide is your final answer. Moving on. That's really it for nomenclature. As we usually do, properties of amides, and we're going to compare it to its um, to its precursors and some of these characteristics. So it will act as a weak base. Again, it came from amines, and amines come from ammonia. So ammonia, if you recall back to grade 11, Bronson-Lowry acids and bases. So acids donate protons, bases receive protons, receive those hydrogen ions. And for that reason, because we still have that ammonia characteristic, it can receive hydrogen ions, so it can therefore act as weak bases. Next characteristic, it's generally insoluble in water except for low molecular weighted amides. And it's less soluble in water because if we think about the structure, we have quite a number of potential alkyl groups here. Now it says low molecular weight amides um, could be an exception because you still have that very polar carbonyl end, that oxygen with its surrounding electrons. So it does have some polar characteristics, but generally, the larger the molecule is, the higher molecular weight it is. That would mean you have larger alkyl groups, larger non-polar ends, which would make it less soluble, less miscible inside a polar solvent like water. And just off of that, a bit more detail, tertiary and secondary amides have lower boiling points than primary amides. So um, from the primary amide, there are more hydrogens to form hydrogen bonds with water and increase intermolecular forces there. Okay, reactions. Not too many to go over for us. I mean, there are more, but we won't go over all of them. The main things you're going to look at here is that amides can revert back into their original precursors that were needed to create them. So amide, again, carbonyl nitrogen group, primary amide, therefore, in the presence of a strong acid. Right, in the presence of a strong acid, it will produce your carboxylic acid from whence it was derived, and in this case, ammonium. Right, so the reactions are typically pretty slow. This nitrogen group is less likely to break apart. Again, these are unique in that they're found in the building blocks of protein, nitrogen-based proteins, and so they should be molecularly evolved to be resistant to these types of conditions. So it's not a it's not a great reaction. Its yield isn't high. It doesn't typically happen too quickly. It's a bit resistant to this, but this is a reaction that we're going to learn today. So as going back before I completely show that, just to prep you for that, going back to this example. Now, going or explaining this example, what you're going to see next might look really boggling, but all you're going to look for is a carbonyl and a nitrogen group. If a question like this were to come up and you were asked, state the final products, all you need to do, here it is, circle it for you. This is a CON, C double bond O. You can assume safely, not assume. You can hypothesize that this is going to be a carbon and oxygen carbonyl nitrogen. Here is your amide, your characteristic amide functional group. Then in the presence of a strong acid, you'll see that it also does happen. This is all based on a mechanism that we haven't learned, that we won't learn, but it can happen with both. in the presence of an acid or a hydroxide, it will break apart into its precursor. So here we'll get your carboxylic acid, C double bond O carbonyl, COH hydroxyl group, and that will be your carboxylic acid. What you're left with then is your amine. Now, lots going on here as well. Something you're not too concerned with. You're looking for what's typical in this reaction. Your amide in the presence of a strong acid or base will give you that. And that's it. So your practice, it says home fun, but we know we try to do this in class. We have a worksheet on amines and amides. After watching this video, we will go over these examples again in class, but we'll have more time to work on these problems, ask questions, and get them answered. That will be it until we do it in class.